Hey guys, I am Gautam and welcome to GKMX. In this video, I am going to talk about Michael addition or what we generally call Michael reaction. Okay, and also the application of Michael reaction or Michael addition, that is the Robinson annulation. So to explain this, let's talk about what is Michael reaction reactant, what will be the reagent, what will be the reaction condition, and what will be the product. Let's talk about that. Then I will be discussing about different things about the Michael reactants and products. Okay, and then finally I will be discussing about the mechanism, and at last you will get about the Robinson annulation and or the application of Michael addition that is important in case of Robinson annulation. So this reaction, first let me say about is important for NET examination, GATE examination, and it's in the syllabus of IIT JAM examination. So it's a very important, very applicable reaction. Okay, so just watch carefully. So let's talk about the first reaction, thing, that is about the reaction conditions. What are the reactants, what are the products, and their characteristics. Okay, so in the Michael reaction or Michael addition, what happens? First one, Michael donor comes. Okay, then this Michael donor will react with one, as it's a donor, so there will be one acceptor. So that is called Michael. I am giving you the examples. Okay, first let me say about this. So Michael donor, then Michael acceptor, and finally along with the presence of a catalyzed base, that is that should, because of the reaction should be fast for these cases. Okay, so and the second is acid workup, that is the H plus or H3O plus or HCl, live HCl, acid workup to protonate the system. Okay, and finally what we get the product, that product we will call Michael adduct. Okay, so from Michael donor and Michael acceptor we get Michael adduct. Okay, so this is Michael donor. So let's take an example about the Michael donor. So this kind of things we call generally Michael donor. Here it's OIT, here it's OIT. Okay, so you know that this system, this one and also this one, these two system, and here 2 proton, 2 H hydrogen is present. Okay, so it's a 2 hydrogen system, so we'll call this system as methylene. And one more characteristics of this methylene is there, so I am coming into this, but let me talk about these two groups. So these two groups, you know, these two groups are the electron withdrawing group, you know, electron withdrawing group. This is also electron withdrawing group. So electron withdrawing group, that means this group accepts electron from the system. So this is the basic features of this Michael donor. So this is called Michael donor. Why it's called donor, I am coming to this. So another is Michael acceptor. So what is Michael acceptor? So let's take an example. So this kind of thing, it's OIT. Okay, so here you know that this group, that is this one, is also CO or COOT, so that is why it's also electron withdrawing group, and this is the R group. So R means and electron withdrawing group. What does it mean? I am coming into this. So this is Michael acceptor. Why it's Michael acceptor? I also coming into this. Just keep watching. And finally we get Michael adduct. So what is Michael adduct? Michael adduct means, say this and this, when these two will react, the product we will get, that is called Michael adduct. So this kind of product, and how this kind of product we get, I will be discussing in the mechanism section. Okay, this is the Michael adduct. Okay, so this is the Michael adduct or the Michael reaction addition product. Okay, so let's talk about these things, and now let me talk about the basic reaction mechanism. Why it's methylene, why this methylene is important, why we are taking this is alpha beta unsaturated ketone, or sorry, alpha beta unsaturated carbonyl compound. This is alpha, sorry, this is alpha and this is beta. So in Michael addition reaction, the reagent should be, the reactant should be one, active methylene system. What does it mean, active methylene system? Active methylene system means these methylene, these two hydrogens should be acidic. That is, this hydrogen is acidic and this hydrogen should be acidic. Why? And here it's also acidic because these two electron withdrawing group. So here if this proton is abstracted by another base or something like that, then one negative charge will be formed right here. So this negative charge, that is that conjugate base from acid, will be stabilized by this kind of resonance. Okay, and also same is true for this reaction, because these are electron withdrawing groups, so this will attract the electron towards itself. Okay, that's why this hydrogen after preprotonation, the negative charge will be formed over here, and that is stabilized through as electron withdrawing groups are present beside in this system. Okay, so these hydrogen and these two hydrogens are active methylene groups, or this whole system is the active methylene system or activated methylene system. Okay, whatever you want to say. So now next coming to Michael acceptor. So acceptor means this, if here its negative charge is forming, so this negative charge is of course it's a delocalized negative charge, but its negative charge is forming over here, so it will act as a base. Okay, as this is a negative charge, so it will not accept for the far more electrons. It will try to donate electrons to other system, so that electron will be accepted or can be accepted by this one. That is why it's called the Michael acceptor. How these negative charge will go, as you know, this is a very bulky group, so it will not approach like that here, because it's a crowding system, very crowded system. So because of this, it will not approach to this carbonyl center. Okay, that's why it will go to this beta center, beta carbon, because of the less steric hindrance. Okay, because of less steric hindrance. So this negative charge, this will donate to this, and whatever it will donate, it will accept that one. That's why it's called Michael acceptor. How I'm coming into the reaction mechanism. Okay, so here it's very important, because you should know about the Michael donor, Michael acceptor, and the Michael adduct. That's very, very important. That's why I am giving so much time in this. Otherwise, mechanism is very, very easy. Okay, so after that kind of reaction and finally acid workup, we will get the product. I am coming into this during reaction mechanism, during showing reaction mechanism. But before that, let me tell you something about the electron withdrawing group and the R group. So it's R group, it's electron withdrawing group. So what one question you can if in your mind may come, that only this one is can be the electron withdrawing group. Actually no. Instead of this, if other groups are present, like say electron withdrawing group, different kind of electron withdrawing group can be present. So here any R group, okay, here like this, instead of this electron withdrawing group, another one that is say CN, another one that is like NO2, another one that is like NR2. Okay, so this kind of whatever the electron withdrawing group, everyone is everything is electron withdrawing group. So whatever comes, everything is electron withdrawing group, and that's why electron withdrawing group, instead of this one, if any electron withdrawing group is present, then that will participate, that will act as a Michael donor, or if it's present in this one, that will act as a Michael acceptor, or that will react, that can be participated in the Michael addition reaction as Michael donor and or Michael acceptor. Okay, so that is about the electron withdrawing group that can be varied, whatever this can be, or this can be, or this can be, this can be, or this can be. This kind of any kind of this system can be acted as a Michael donor or Michael acceptor as electron withdrawing group. Okay, so its electron withdrawing group is over. So now coming as R group. So what are the possible R groups? So R groups basically can be hydrogen, you know, their air should be on hydrogen. Then another is any alkyl group, okay, alkyl group, or finally any aryl group. That means here it's a pH, that's the aryl group, of course. Okay, so hydrogen, it's maybe alkyl group or any kind of aryl group. So instead of R group, this R group here, hydrogen, alkyl, aryl, or instead of electronegative group, there may be one of these. Okay, so this is the basic introduction of the Michael addition reaction. Okay, so now coming to the mechanism. Okay, so first let me draw the so this is the active methylene system, 1,2 methylene. So first, as I have told you that the reaction the catalyzed base, so catalyzed base will be NaOH, okay, in presence of ETOH. So NaOH is a source of OH minus, so this will accept this hydrogen atom and one negative charge will be formed over here. So the product will be okay. So this negative charge is resonance stabilized. I am not showing because this kind of resonance stabilization will occur and we will get two resonance structure. Okay, so I am not showing those. So this negative charge is resonance stabilized. Okay, so now in the second step, what will happen? This is what is that? This is Michael donor, MD. Remember this one, and we have to now take one Michael acceptor. That is, I have shown you in the section. Okay, so this negative charge will come to this because of this steric hindrance. It will not approach to this carbonyl center. Then this kind of resonance, will occur over here. So what will be the product? So the product will be like this one, then one, and finally this will come like one pH, another 1 2 3 1 2 3. So this is one negative charge, and finally, so this will not be double bond, this will be on O, there will be negative charge, double bond, and there is one negative charge. Okay, so this is the reaction mechanism basic. So this is the reaction in the first step. So in the second step, as I have already told you, the reaction acidic workup should be occurred. So now in presence of HCl or any acid, dilute HCl, what will be the product? So the product will be like that. So this one OIT, this one OIT, then this is pH 1 2, and in presence of this O minus will be the OH. This is OIT and this is OH. And after tautomerism, okay, after tautomerism, this will be like that. 1 2 3, there will be negative charge and there will be a hydrogen. That is equivalent to, you should, if you have write anything, you don't write anything. Okay, it's over. Okay, so now it's the reaction, it's the final product of this reaction. Okay, so this is called Michael adduct. This is called, so whatever the reaction in the second step, that is called Michael acceptor, Michael donor, that is called Michael acceptor. I have that is right here, over here. So that is Michael acceptor. This is called Michael adduct, donor, acceptor, adduct. Okay, so that is not Michael acceptor, that is actually Michael donor. Whatever I have, it was in the previous one, but during writing this, the product, I cleared the board, so that was the Michael acceptor, whatever. So now let's talk about this is the product of Michael addition, and now let's talk about the Robinson annulation, which is one important application of Michael addition. So what is Robinson annulation? So Robinson annulation is nothing but the Michael addition reaction, but the product will be cyclic. Okay, the product will be cyclic. So how? So let's talk about that. So in Robinson annulation, what happens? Let's take this ketone compound R1, R2. When it is treated with one base, that should be of course the strong base, likely to be NaOH, and in the presence of another alpha beta, this is alpha, this is beta with respect to this keto group, unsaturated carbonyl compound. Okay, so this is say R3. So in presence of this alpha beta unsaturated compound, along with the base, this keto group will react with this one, and finally the product will be a cyclic product. So basic difference between the Michael addition and Robinson annulation is, in Michael addition you will not get the cyclic product, but in Robinson annulation, that is one type of Michael addition that gives the cyclic product. Okay, and this is R3. So what about how do we get this kind of product that I am going to discuss in this video. Okay, so why we get this cyclic product, or how we get this cyclic product? So this is one likely to be Michael donor, like Michael addition reaction. This is Michael acceptor, and this is called Michael adduct. Okay, so Michael donor, Michael acceptor, and Michael adduct, that is a product. So Michael acceptor means, Michael donor means that will be the activated methylene system there will be. Okay, so this is R1, this one R2, there will be two methylene system that is acidic. And why it's acidic? Likely to be the same the previous one, because this hydrogen is, after generating this carbon ion is resonance stabilized with this ketone. That's why it's it will easily form the conjugate base. Okay, and that's why it's acidic. So in presence of NaOH, that is the source of OH minus strong base, this negative charge will be formed, and then this kind of resonance will occur. So finally we get one negative charge, double bond, then R2. Okay, so this find then attack likely to be this Michael acceptor, that will be acceptor. The beta position is less hindrance than the keto group, that's why it will attack, this negative charge will attack to the beta position. How? Let's see about the reaction mechanism in the second step. R4, this is R3, this is keto. So to react this, let me use different color. This kind of reaction mechanism will occur, this beta position, then this kind of resonance will occur, or rearrangement will occur. Then what we get? We get the product like this, R1 O minus, sorry, this will be not O minus, this will be keto. This is R2, this is 1, this is R3, another one, then this will be keto. Okay, and this will be R4. Okay, sorry, I have done one mistake over here, that is CH to R4. So here it will be CH to then R4. Okay, now everything is okay. So now in the next step, what will happen? The reaction will occur like this. Okay, so now in this system, that is this kind of resonance actually I have drawn after the tautomerism, but what actually happens, there will be one negative charge over here and there will be one O minus. Okay, so in presence of water, because it's a dilute NaOH system, so in presence of water, this kind of resonance will occur, and that will accept the H plus proton, and OH minus will leave the system. Okay, and thus it will be protonated. Okay, so if when from this H2 OH minus leave, the deprotonation of the system will occur, and the product we will get like this. This is R3 to 2 double bond O CH2 R4. Okay, so this is the product in this reaction till now. So So in the next step, what will happen? You know, this system, there is two methylene system that is also activated because of this keto group, okay, and also acidic. So now in presence of OH minus, this keto will attack this one and this kind of resonance will occur and we get the product like this. So I am writing this bond rotating after rotating, okay. So this is R2, this is double bond O, and this is R1, and then this is R3, then so okay, let me draw like this. So this is O minus, this is double bond, and this is R4. So after this kind of reaction will occur. Okay, this is about the Robinson annulation. So now what will be the product? The product will be 1, 2, 3, 4, 5, 6 numbering. So if it is this one, and then the product will be, okay, not like this, the product will be, this is O minus and this is R1, and then this one will be R4, okay, this one will be the keto, this one will be the R3, this one will be the R2. So now the product in the next step will be, in presence of course water, this O minus will be protonated and we get the product like this, R4, R1, this is OH, this is keto, this is R3, this is R2, and finally the H2O will leave the system because of the presence of the strong bases. Okay, so you can think like that there is one hydrogen over here, there is OH over here, so because of this. So after that we get the product like this, okay, this is R3, this is R2, this is R4, and this is the final product what we get. Okay, so this is the Michael addition, but modified Michael addition you can say, or Robinson annulation, because of the formation of the cyclic ring. Okay, it's likely to be same as Michael addition, but the application of Michael addition and is called Robinson annulation because of the discovery by the scientist of the Robinson. Okay, so this is all about this reaction, and if you have any query regarding this reaction, or one more thing, that here also there may be present different R group, there may be present different slightly different Michael acceptor, Michael donor. Okay, so just take care of this, just remember this reaction regarding the base, that is NaOET, ETO is like that, or the alpha beta unsaturated carbonyl compound, okay, that is Michael acceptor, and Michael donor, that is active methylene group. So active methylene group, alpha beta unsaturated carbonyl compound, and NaOET is the way to remember or to identify the reaction, that it is Michael addition or it is Robinson annulation, like that. Okay, though both are same, but just remember this one, that when in system there will be active methylene group, that is of course acidic methylene group, that and the alpha beta unsaturated carbonyl compound or ester, like that, or and along with that the NaOET is base, like that base are present. So then you can easily identify the reaction as Michael addition or Robinson annulation. Okay, so that's all about these reactions, and thanks for watching.